In 3.2, we're going to cover quadratic functions, and then at the end of the section, we're also going to look at circles. First of all, let's look at what our quadratic functions are. So I know we're all familiar with this. You may not be used to using this p of x, and the only reason why our book is using p of x is because quadratic functions are just a special form of a polynomial. So in a later section, we're going to be talking about polynomials, and we'll be using this capital P. So it's just a function, p of x equal to ax squared plus bx plus c, and I know we're all familiar with the ax squared plus bx plus c. So a and b are just real numbers. Here a cannot be 0, but it's okay if b or c is 0. Now the graph of a quadratic function, that's just called a parabola. Again, I know we're all familiar with that. Since these are functions, we're only looking at parabolas that open up or down. There are parabolas that open left and right, but those are not functions, so we're not going to talk about these in this section. Basically, if you have a parabola that's opening up, so like this first example here, so if it opens up, that just means the a value, that leading coefficient on the x squared, is positive or greater than 0. And if it opens down, like this second example, that just means your a value is negative or less than 0. So all parabolas are symmetrical about the axis of symmetry. In these particular examples, it looks like our axis of symmetry is the y-axis, but it doesn't necessarily have to be that way. So the axis of symmetry is any vertical line that will cut your parabola in half so that the two halves are mirror images of each other. And it is a line, so it has the equation x equal to some number. So again, this would be our axis of symmetry. And again, if it opens down, it has an axis of symmetry as well, cutting it in half into two pieces. The most important point on our parabola would be the vertex. In the case where we're opening up, the vertex would be the lowest point. So since it's the lowest point, we say that it gives us the minimum value, and I'll just write min. In the case where we have opening down, our vertex would be the highest point, so it's going to give us a maximum value. When we talk about minimum and maximum values, we're talking about the y values. Okay, some other things that we might want to note when we talk about our vertex is that when we're graphing a parabola, the vertex is our starting point. That's one reason why it's the most important point. So once we have our vertex, all we have to do is either go up or down and our parabola is drawn. Now, in the real world, parabolas can be used to model many things that are affected by gravity, such as if you throw a ball into the air, it's going to go up, it's going to come down. And oftentimes, the vertex is the most important point because it gives us like the maximum height of an object that's thrown up in the air. So we use parabolas quite a bit. And since the vertex is the most important point, we want to know how to find the vertex. Again, I know this is all familiar to you, but remember it's negative b over 2a. That would be the x value. So the vertex is a point where the x value is negative b over 2a. So once you find that x value, you just put it into your function to find the y value. So again, this is going to be an x value and a y value, and the vertex is a point xy. Okay? So the x value is negative b over 2a. In example 1, we have this parabola, or this quadratic equation, negative 3x squared plus 6x minus 5. And we're going to graph it, state the axis of symmetry, the domain, and the range. So the first thing I want to do when I graph is I want to find the vertex. That's my starting point. So notice that in this particular quadratic function, my a is equal to -3, so I know it's going to be opening down. I also know that b is equal to 6 and c is equal to -5. So when I find my vertex, it's going to be an x and a y, where the x value is -b, which is 6, over 2 times a, which is -3. So my x value is going to be -6 over -6, which would be a +1. So I'm going to take that +1, I'm going to put it back in my function for x to get y, which would be equal to -3 plus 6 minus 5. So it looks like y is going to be -2. My vertex is the point 1, -2. I'm going to graph that. And I know that a is negative, so this is going to open down. So I simply have to draw a parabola opening down from my vertex. Problem is, I don't know how wide it is. So I'm going to need at least one other point. Usually you need 3 points. You need the vertex and 2 other points to get the width of your parabola to be able to graph it. So now notice, I'll make a table of values. Notice that I have already x is 1 and y is -2. So I'm going to pick an x value near 1. 0 seems reasonable. Put that in my function to get -5. And I have 0, -5 as another point. I'm going to use this axis of symmetry, and I'm drawing it as dashed because it's really not part of the graph of my parabola. To note that if I have this point that is 1 unit away from the axis of symmetry, and if I go 1 unit in the other direction, I get my other point. Now I have 3 points I can graph my parabola. So the rest of this question said to state the axis of symmetry. The axis of symmetry is this line. Remember, it's a line. It's a vertical line, so it's an x value. And since it's passing through an x value of 1, the equation of the axis of symmetry is x equal to 1, which will always be the x value of your vertex. So your axis of symmetry, x value of the vertex. And in this case, it's 1. We also had to state the domain. With all quadratic functions, the domain will just be all real numbers, so -infinity to +infinity. You can put anything in for x. It's your range that's going to be restricted. And that is because we have either a highest point or a lowest point. So we either have a highest y value or a lowest y value. In the case of this particular graph, you can see that my y value, the highest, largest y value I have is -2. But I get all the smaller y values, which means our range is going to go from -infinity to -2, and we can include -2, so it's a bracket. So it would be really nice if we had an equation where we could just look at it and actually see what the vertex is, since the vertex seems to be the most difficult thing to find when we graph our quadratic functions. In the standard or vertex form of the quadratic function, it's written so that we can easily identify the vertex. So in this case, our p of x is a times x minus h squared plus k. So notice that the hk, that's our vertex. So it's already written in the form where we can identify the vertex very easily. And also notice that it's written in the form of a transformation. So once you have the vertex, you can use that a, which would be it would be a vertical stretch shrink. And then the plus k would be a shift up down. So how do you get the general form to be in the standard or the vertex form? We complete this square. And if you have never completed the square or you forgot how to complete the square, we'll do it in example 2. But basically, if what you're given is not a perfect square trinomial, then you could do the process of completing the square, which just means you're going to add something to it so it becomes a perfect square trinomial. But whenever you add a value to your function, you also have to take that same value away. So you're essentially just adding 0. You're not changing the function. You're just writing it in a different way. Let's go ahead and do example 2 so I can either remind you or show you how to complete the square. 2x squared plus 4x plus 1, that's not a perfect square trinomial. I can't factor it into something squared. So the first thing I want to do is I want to make sure my x squared only has a 1 in front of it. This one has a 2. So I'm going to factor out that 2 from just the x portion of it. So it'll look like this. F of x equal to 2. And I'm going to factor it out from the x's. So it becomes x squared plus 2x in parentheses. And we still have that plus 1. Now, inside the parentheses, the x squared plus 2x, that's what I want to complete the square on so that I have a perfect square trinomial. And you might look at it and say, oh, well, all you have to do is add 1 because x squared plus 2x plus 1 is a perfect square trinomial. It's x plus 1 squared. But if you don't see that, the process is whatever is on the 2, or whatever's on the x, which in this case would be 2, the process is take half of that and square it. That's what you would add in, okay? So this is 2. We're going to take half and square, which gives us a 1 squared, which is simply 1. That means I'm going to add 1 inside the parentheses to get x squared plus 2x plus 1. Let me write that. So now inside the parentheses I have the perfect square trinomial, which will factor into x plus 1 squared, but I can't simply add a 1. And we still have this 1 on the outside because I'm changing the value. So whatever I add in, I have to also subtract out. So I added in this 1, but we have to be really careful because I didn't just add 1. Remember, we had this 2 on the outside. Imagine if I were to distribute that 2 back through. I would actually get 2x squared plus 4x, which is what I started out with, plus 2. I'm actually adding in 2. So if I add in 2, I have to also subtract 2 so that I have not changed the value of my function. Let's put all of this together. This is going to be 2. The x squared plus 2x plus 1 becomes x plus 1 squared. And if you don't realize how it factors, look at what we factored out above. This was a 1 squared. It's a positive 1 squared. And then on the outside, I have plus 1 minus 2 becomes a minus 1. So this is my function written in the vertex form. And I've completed the square. So half squared of whatever's on your x, add it in, but then you have to subtract it out. But just be aware that you're going to have to multiply it by the number that's outside of the parenthesis. Now that I have this in the vertex form, I can see that my vertex is going to be -1, -1. So think about the vertex as the x value is going to be whatever inside the parenthesis, whatever x value gives you 0. So if I put in -1 for x, -1 plus 1, that's 0. Another way to look at it as this is a transformation. Now remember that whenever we do something to the x, it's kind of opposite of what we think we need to do. So if it's a +1, remember that would be a shift left to the negative. So if it's a +1, you do the opposite, you do a -1. But the -1 on the outside, that's the y. That's affecting our shift up and down. So whatever it is whatever it is. So our y value will always be whatever's on the outside of the parentheses, which in this case is -1. We have our vertex, -1, -1, but we also know that it opens up because our a value was a +2. In the vertex form, you get vertex gets opens up. All we need is another point and the axis of symmetry to graph. So -1, -1 opens up. I'm not even going to make a table of values. I'm going to use the axis of symmetry. Remember, that's going to cut my parabola in half. And then when I find another point, which it seems reasonable in this case to pick x is equal to either -2 or 0, pick a x value close to your vertex. So if x is equal to 0, and I'm putting the x into my original function, 2x squared plus 4x plus 1, to get a y value of 1. And it's going to pass through the point 0, 1. I know it opens up. I also know I have another point same distance away on the other side of my axis of symmetry. And I have my parabola. You could get more points if you want, but this is fine. Let's do this one more time, since this process of completing the square may be new to you. Notice that there's no c value in example 3. That's fine. As long as there's an a, we're good. B and C can be 0. First thing I want to do, and I used y instead of f of x or p of x. First thing I want to do is I want to complete the square. So this is going to be y equal to factor out the -4 to get x squared minus x. Okay, so now I need to do half of the number on the x. Notice that this is -1x. So I need to do half of the number on the x. So -1, take half of that, square it, and I'll get 1/4. I need to add 1/4 inside the parentheses. So this is going to be -4 x squared, minus x plus 1/4. So I added 1/4 in, but I need to subtract that 1/4. However, I have the -4 in front. So remember, we're supposed to multiply those two together and then subtract that out. So that would be -4 times 1/4. Let me write that down up here. That would be -4 times 1/4. That would give me a -1. So I'm supposed to subtract -1, which is the same as adding 1. This becomes -4 x. How does this factor? Go back to the -1/2 squared. So it's going to be -1/2 squared plus 1. Okay, so half of the number on the x squared. Add it, subtract it. Don't forget to multiply by that a value. And that's also half of whatever it is how it factors. So this is -4 times x minus 1 squared plus 1. It's in the vertex form, where the vertex is going to be 1/2, 1. So I'm going to go to 1/2, 1. This opens down. So I'm going to go down from my vertex. I need some more points to see how wide it is. Again, pick an x value that's close to an x value of 1/2. In this case, 0 again. If I put 0 into it, I'm going to use the original function because it's easier. If x is 0, y is 0. So it's going to pass through 0, 0. And because of the axis of symmetry, I'm going to have this other point, 1, 0, and I'm done. Come on. So now we're going to take a little side trip and see how we can apply this idea of completing this square to something that's not a function, but something that we ran across quite a bit is a circle. So again, recall that a circle is simply the set of points from some point which we call the center. In this case, our center is going to be this point HK. So on the graph, we have our center. We're going to go some distance r, which we call our radius, out from the center. And then our circle is just made up of all the points that are a distance r from our center HK. Now, if we have the equation of a circle written in our center radius form, then we can easily identify our center HK and our radius. However, if you have the equation of your circle in the general form, it's very, very difficult to identify the center and the radius. So the goal here is to go from the general form to the center radius form. But first, let's look at example 4, where we actually have a circle that is written in the center radius form. If we were to graph this, our center is -2, or +2, sorry, -3. So we're supposed to be using values that make whatever's in the parentheses 0. So if x is 2, x minus 2 is 0. If y is -3, -3 plus 3 is 0. We have our center, which is 2, -3, and I'm going to graph that on the graph. We also have our radius is 2, and that's because r squared is 4, which means that our radius r is 2. We always choose the positive value. I'm just going to go out 2 units from my center, so I'm going to go to the right, up, left, down, and simply draw my circle. Okay. So that's a circle with a center of 2, -3. And then we have this radius, which is our distance out, which is 2. And typically you would label your center and your radius when you graph a circle. The last example, all we're going to do is apply this idea of completing the square so we can actually take the equation of this circle and write it in the proper form. I know it's a circle because I have x squared plus y squared, and then I have some other stuff. All right. First thing we want to do is we want to group our x's together, and then we want to group our y values together so that we can complete the square on the x's and the y's. This becomes x squared plus 4x, so I'm grouping my x's together, plus y squared minus 2y minus 4 equal to 0. I'm going to look at my x's and my y's separately. If I look at those x's and complete the square just on the x's, I'm going to take half of the 4, so that's 4 over 2, and square it, which gives me 2 squared, and I get 4. So I'm going to add 4, and I'm going to put this in parentheses to the x squared plus 4x, plus, we're going to look at the y squared minus 2y. So the minus 2y, we're going to take half and square. That's going to give me negative 1 squared, which is positive 1. So I'm going to have y squared minus 2y plus 1. And then I had this minus 4 on the outside. I've added in a 4 and a 1. Notice that I don't have a value outside the parentheses to multiply that by. So I've completed the square, added in a plus 4, a plus 1. So I'm going to have to minus 4, minus 1 on the outside. And then that was equal to 0. The x squared plus 4x plus 4 factors as x plus 2 squared. Again, if you forget how it factors, just go back up to when we took half of. It was a positive 2 squared, so it's a plus 2 squared. Now if we look at the y's, remember it was a negative 1 squared, so this factors as y minus 1 squared. And then the minus 4, minus 4, minus 1 would be a minus 9. The last thing I want to do is get that minus 9 on the other side by adding 9 to both sides. And I have it in the center radius form. Center is negative 2, 1. The radius, r, is 3. And I'm done. I go to negative 2, positive 1, and then go 1, 2, 3 out from my center and draw my sad looking circle. And that's it for this section.